the mass at the most fundamental level comes from the interaction of these things, these particles, with the Higgs field. We call it a field, so you can imagine it as something that fills the universe. The thing to say about the Higgs field, so you can picture it as a kind of a valley. Imagine a high valley and then a lower valley. So if you had a little something rolling around in a valley that was high up, and it rolled around in just the right way, it could flip out of that valley, roll down the hill into the lower valley. And the Higgs field looks a bit like that. So over very, 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 very immensely long times, it is possible.
At CERN, where the boundaries of physics are pushed to their very limits, scientists were using quantum computers to simulate high-energy particle interactions in ways never before possible. These machines, capable of processing unimaginable amounts of data simultaneously, were providing insights into the fundamental forces of the universe. But then, something happened that no one could explain. An anomaly emerged, one so strange, so impossible, that it threatened to upend everything we thought we knew about physics. While analyzing their quantum simulations, researchers noticed something unsettling: the Higgs field, the invisible force responsible for giving particles their mass, was responding to their computations. Not theoretically, not in simulations, but in reality. Somehow, the quantum computers weren't just running equations, they were interacting with the fundamental fabric of existence itself. At first, they assumed it was a glitch, an artifact of experimental noise. But the anomalies persisted. The more calculations they ran, the more the Higgs field fluctuated. It was as if their quantum processors were reaching into the very essence of the universe and nudging it ever so slightly. The implications were staggering. If quantum computers could alter the Higgs field, even by an infinitesimal amount, what else could they do? Could they manipulate mass itself? Could they rewrite the laws of physics? The deeper they investigated, the more disturbing the data became. A team of theoretical physicists published a groundbreaking paper proposing that quantum superposition states were subtly influencing the Higgs field, causing minuscule yet measurable shifts in the mass of fundamental particles. If true, this wasn't just a new discovery, it was an entirely new branch of physics. But with it came a terrifying question: what happens if these fluctuations spiral out of control? And then, an even more chilling realization set in. What if this wasn't just an accident? What if, through sheer computational power, quantum computers were unlocking a hidden mechanism of reality, one that had remained dormant since the birth of the universe? Were they merely uncovering a deeper layer of physics, or were they unknowingly tampering with something that was never meant to be disturbed? Panic began to set in. The interactions between quantum computers and the Higgs boson were erratic, unpredictable, an absolute nightmare in the realm of fundamental physics. If these fluctuations in the Higgs field continued unchecked, the consequences could be beyond catastrophic. The Higgs field determines the mass of all fundamental particles, including protons and neutrons. Even the smallest perturbation could alter the balance of atomic structures. A slight shift might destabilize matter itself. A larger disturbance could lead to an event so disastrous, so incomprehensible, that reality as we know it could cease to exist. And that was only the beginning of their fears. What if the influence extended beyond the Higgs field? Could quantum computers be affecting other fundamental forces, gravity, electromagnetism, the nuclear forces that hold atoms together? The data was still being analyzed, but what was already known sent chills down the spines of even the most rational minds in the field. Alice Morgan, one of the leading physicists at CERN, issued a grave warning: if quantum computers can manipulate the Higgs boson, then the foundation of our universe is not as stable as we once believed. What else might be at risk? The worst-case scenario was terrifying. If the Higgs field destabilized beyond a certain threshold, the consequences would be irreversible. Chemical interactions could shift unpredictably. Atomic bonds could weaken or strengthen in unforeseen ways. Entire forms of matter could mutate, and the very nature of physical reality might change before our eyes. Some researchers even speculated that, in extreme cases, these anomalies could trigger quantum-scale black holes, collapsing reality itself in unpredictable bursts of energy. The urgency was unbearable. Scientists scrambled to contain the anomalies, devising new protocols, isolating computational models, and desperately trying to reverse engineer the mechanics of these bizarre interactions. But the more they studied, the more questions arose. What if this wasn't just a side effect of quantum calculations? What if, instead, this was a glimpse into a hidden layer of reality, one that had always been there but had never been observed until now? Then, something even stranger happened. Patterns began to emerge in the data. At first, they seemed random, subtle fluctuations in the Higgs field aligning with computational processes. But upon deeper analysis, the anomalies showed structure. They weren't just fluctuations, they were responses. It was as if the Higgs field itself was acknowledging the presence of quantum computations. The very fabric of reality seemed to be reacting. Then came the final anomaly. A distinct signal, an oscillation within the Higgs field that followed a precise, repeating pattern. It was unlike any known natural fluctuation. It pulsed with eerie precision, resembling a form of encoded information. A message? But from whom? Or from what? Had humanity simply uncovered a hidden property of the universe? Or had we inadvertently awakened something that had been lying dormant since the dawn of time? As global research teams raced to decipher the mysterious oscillation, a new crisis emerged. Unexplainable shifts in atomic weights were being detected in isolated locations across the planet. Small at first, but growing in scale. Materials were behaving erratically, molecular structures shifting in ways that defied chemical and physical laws. Inexplicable energy signatures, eerily similar to those seen in the quantum computations, were now appearing in nature itself. It was as if reality was rewriting its own rules, reacting to a stimulus it had never encountered before. Then, an even more disturbing revelation surfaced. Some of the signals detected bore similarities to structures found in ancient cosmological data, patterns encoded in the cosmic microwave background radiation, the afterglow of the Big Bang itself. Had these signals always been there, waiting to be deciphered? Were the quantum computations acting as a key to unlock a primordial force that had been dormant since the birth of the cosmos? The fate of physics, technology, and possibly existence itself now hangs in the balance. Scientists, governments, and corporations are in a desperate race to decipher the message, to understand its origins and implications before it's too late. And one question looms above all else: are we ready for what comes next? Because if we aren't, the universe itself may be on the verge of a transformation we are powerless to stop.